So today, we will talk about registers basically. Till now, we have worked on the combinational circuits,
Okay.
which is not holding any memory, right? It is like uh, in no time that, or in very, or we can say very little time, the data moves from one place to other place. It never holds the data. Basically, we don't know is it holding the data for certain time or not, previous data. So basically, today we'll talk about registers. Registers basically hold the data, okay, for certain time, for certain period of time, and that period is basically depends the it's called frequency basically. So for if for a given frequency, uh, each cycle data is will be held in the register, and it will only change to the next cycle if we change the input. That's the register. It can hold the data basically. Okay. So I will not go more into the what kind of latches are there, or what kind of flip flops we have seen. Mainly, we'll directly jump into the D flip flop.
Okay.
This is widely used in the digital circuits.
Okay.
Okay, we don't use any other kind of flip flop in the circuits. Okay. So I will talk what is this? Basically, it's a D flip flop. Okay. And what is D flip flop? It's uh, whenever it's having two parts basically. One part is taking the input, and other part it will hold the input for certain time. Okay.
Mm.
So whatever uh, basically this there's a clock to the uh, input, and one is data input. So when you see what will happen, let's say we given one data on the D. Okay. And
Mm.
this is an AND gate, right? So and clock will be half cycle period, it will be one, and half cycle it will be zero. So first half cycle, these two are one, right? Because D is one,
Mm.
and this is NAND of D, basically not of D, so it is zero here. So and this output will be what?
Mm.
1 1, and output is one, and then since it's NAND, so here it will be zero. So whenever the clock is one and D is one, the output will be zero here, and
Okay.
at the same time the output will be one here, right? Because this is zero, and then any input of any input to the NAND gate is zero, the output will be one. So here we'll see zero and one when the clock is one and D is one. Okay. And what will happen when the clock is zero? What will happen when the clock is zero? Nothing will change here, right? Why? Because when the clock is zero, D is not changing. So it will keep any change on the D will not be seen here, and it will keep holding the data like Q and Q bar. And once the again the when the clock is one and D is changing, basically if you change the D, it will the change will occur here. And when the clock is zero, it will the change will not be seen here. It will hold the data
Okay.
because there's a feedback here. Okay.
Mm.
So that's what the truth table says. Like when the clock is zero, the whatever D is there, it will not be seen here, and no change on that. It will hold the previous data. And when there is a one, clock is one, and zero is there, D, and then Q will be zero because they're transparent. D flop, we said transparent flop. So whatever input is there, it will be seen on the Q, and inverted of that will be seen on the Q bar. Okay, so this is a truth table, and if we see the how will be timing diagram. So clock is like this, right? So this is a rising edge, and this is a falling edge. Rising edge is this one, and the falling edge is this one. Okay. Mm. So what will happen? So you see here uh, means what any change when it's zero, it will not be seen anything, right? So so what will happen, like when the d is like some value is there, right? um, so like d change will be seen only on this edge, right? Because whenever this become 1, and on the rising edge basically, so when these one, the change on the Q will happen here at this rising edge. So it's a rising, always it says a rising edge flop, right? So
Okay.
whenever D value will be like at this rising edge, the data is seeing as a 0, and at this rising edge, so one more thing you understand, like you'll be confused, like why D is 1 here, right? So why we are not, why we are not seeing the 1 here itself? Because already for certain time 0 is flown here, and then that has set the value here already. And when basically like any means the flip flop works on the rising edge or the falling edge. So and the flip flop any change should be seen on the rising edge only, or the falling edge. So since this is a rising edge flip flop, we will be seeing any change on the data D will be sampled on the rising edge. Okay.
Mm.
At this rising edge, it is 0 here. So and this will be sampled here 0. So we see the Q output 0 here. You see the Q is not changed. And but at this rising edge, it has sampled D as 1. So Q has changed here, and then Q bar is changed here. Okay.
Mm.
And D flip flop looks like this. So means if you symbolize like how to represent a D flip flop in the diagram, so we symbolize like this. There is a D input and the Q output, and then Q bar output is also there, but we generally don't use the Q bar output. Okay. So in real like hardware, we don't represent the Q bar. We just use the Q. Okay. And then clock is there, and then preset and set like preset will do the whenever preset is 1, or then the output will be hold as a 1, and when the reset is 1, output will be 0
Okay.
basically. So we can clear, basically we can asynchronously clear, like uh, anytime we can. So what we will design, there can be one more thing is there, like asynchronous reset and synchronous reset. So asynchronous reset means like irrespective of the clock, anytime we make the reset or preset uh, based on the active low or active high. If we set that, it means like, and the outputs immediately changes. It's called asynchronous. So irrespective of the clock, uh, if the output react to the preset or reset input, is called asynchronous reset or preset. Okay. Or preset. And what is synchronous reset or preset? Irrespective of the change on the input, preset or reset, the change is seen only on the clock, rising clock edge, and then that change impact the output on the rising clock edge only. That's called synchronous. Okay. So how it will look like in the like timing diagram, like uh, means how it will be a synchronous reset, or how it will be a synchronous reset. I will just draw the timing diagram. Let's say. Okay. Let's say this is clock. Okay. This is, let's say, it's active low. Set. Okay. And this is D. Okay. And this is D. And this is Q. So what will be Q here? So I said, right, this is asynchronous preset. Okay. Or we take reset. Okay. Reset. Asynchronous reset. Reset means the Q should be zero, right? And let's say the D here also. Okay. D was like this. Okay. Asynchronous. So I said, right, like whenever this is positive edge, right? This is rising edge. This is rising edge. And this is rising edge. This is rising edge. Another rising edge. I said, right, at the rising edge, whatever D value is there, it will transfer that value, okay, to the Q. So at this rising edge, what is the T value?
0.
0. So Q will be 0 until the next rising edge, okay. At this rising edge, what is the value of D?
1.
Just at this rising edge, what is the value of D?
Yeah, 1.
But you see, right, what I said, right? It's a asynchronous reset, okay. So
Hmm.
as reset will always take priority on the D, okay. So irrespective of the D, the output will be changed according to the reset, okay.
Okay.
And since it's a asynchronous reset, so reset is changing here only, right?
Yeah.
Before the rising edge, okay. So what will happen? Like Q will immediately go 0 irrespective of the rising edge of the clock.
Okay.
So what will happen? The Q will become 0 here only, okay? And it will remain 0 until the reset is there. Okay, reset is here, right?
Yeah.
But so it will remain 0, okay? And but at this rising edge, what is D seen? 0 only, right? So it will remain 0. At this rising also it's seen 0, 0. But at this rising it's seen 1, okay? So it become 1 here. So it will the Q will look like this, okay?
Hmm.
But at the same time, this is asynchronous, right? I say, right, irrespective of the rising edge, whenever there is a change on the reset, it will impact Q. Let's draw. Let's understand the right. Synchronous. Let's understand the synchronous reset. Okay.
Hmm.
Again, draw the clock. And reset again. Draw. This is this is reset. This is D. This is D. This is Q. This is rising edge. This we are telling like it's a synchronous reset. Okay. synchronous reset. So at this time reset is not there, right? So it means like it will take D will take priority because reset is not there. So reset is not taking priority. So so what will be like D here? D is 0, right? So it
Yeah.
will remain 0. And here D at this rising edge, the D is 1 will change here. Okay. Now I'm telling like you see the reset is 1 here only. But since it's a synchronous reset, right? This change on the reset will not be seen. Okay. The
Mm.
change on the reset will be seen only on the rising edge of the flop. So it sees the reset here and then it goes 0 here. Output. Okay. And the reset is seen again. Change reset. This 0 of reset is again seen here only. So it will change here. Okay. And sorry, it will remain 0 because D is 0, right? It will take T will take priority. So here you see like reset is not there, and so it will D will take and D is also 0, so it will remain 0. And at this point D is 1, so it will become 1. Okay, so you see the like difference in both diagram is like the the Q is changing in the synchronous reset only on the rising edge of the rising edge when the reset is active, and here the Q will change immediately when the reset will change irrespective of the clock edge, right? This is the difference between synchronous reset and asynchronous reset. Okay, any question here?
No, I don't have question.
So let's design the reset registers basically. So create project.
So the clock, how do we add the clock there in the VHDL?
Yeah, so clock is an input, right? So we'll drive the source. Source. So what inputs are there? We say right, there's a clock input, clock in std underscore logic. Either like preset. So we said right, we can have either both or one, okay, or reset or preset, one of them. Let's say we are designing both, okay. Yeah. D input, right? We can say D. Let's be D. Q output, right? A1 output. Mm. So clock is one more thing you understand, in VHDL clock is always used in rising edge can be used in process only. Okay, we can know where we can write the rising edge detection outside of the process. So we have to use the process to use a clock.
Okay.
Okay, and you remember I said right sensitivity list. Okay, right? You remember or not?
Yeah, yeah, you said it.
In bracket we write sensitivity list. Okay,
Yeah.
you remember I said right all the inputs to be there in the uh,
Case statement.
not casted in the sensitive list. All the inputs used in the process should be there in the sensitivity list. Okay,
For
so
the when we are doing the case statement also, right? That we put.
yeah, case statement also. So input was like marks in, whatever marks in and select, right? We put there those things, all right? But in in the clock process, or we can say where there is a like memory is there in that process, when the change should occur. So this basically says right change occur like when the sensitivity list sends any change on any of the input, it goes inside and executes something. Okay, right?
Yeah.
And in case of flop, when the change is sensed,
That
change is
is
sensed only when the clock is rising edge,
rising
or
edge.
clock is changing, or the reset is changing, right?
Yeah.
In case of in case of so any change should occur either on the rising edge of the flop, okay, or if it's a asynchronous reset, it is a asynchronous reset. Okay, change should can occur anywhere here, right?
Yeah.
Or if it's a synchronous reset, only change will occur on the rising edge, right?
Yeah.
Right. So now currently now we are writing the asynchronous reset.
Okay.
Synchronous reset.
So we always use the D flip flop. There is no other flip flop use, only D.
Yeah, so always RTL will always the VHDL or any language will make a D flip flop only.
D,
Always.
positive edge. D flip
Yeah.
flop.
No, it can be both edge. That's I'll tell you how to write at the edge. Okay,
Okay.
but it will always make a D flip flop. Okay. So I said right, we are making a synchronous reset flip flop. So a synchronous reset flip flop means the change can occur either on the rising edge of clock or the reset. Okay, and or the preset because we are using the both, right? So or the preset. So here we should write uh, clock comma reset comma preset. Okay, but now these also are input, right? But we are not using that input because we are not, whenever we are going inside the process to execute, d is already there. D already changed. We don't need to see the d changes. D, whatever d value is there, we will take that. Okay,
Yeah.
we are not bothered about the d change when d is changing. Okay, we are seeing only the d. We are taking the d value when the clock is one or the reset is one. Okay, so that's why d is not used here. So in the clock process, either reset, all the reset and clock will be there when it's a synchronous reset, and when it's a synchronous reset, only clock will be there. Okay, this you keep in mind.
Yeah. Okay.
So I said right. The one more thing I said right. The priority will be taken by the reset or preset over the clock, right? In a synchronous reset, right?
Yeah.
That I already said. So it means like the first statement we have to write if. Okay, reset equal to 1, then else if reset to tick 1. Okay. Else if the clock equal to tick 1. Okay. I'll tell you one thing and then and if there's no else, okay, nothing will happen other than that, right? Because we have to execute only on this edge. This is 1 or the reset is 1. Only 3. Else we don't want to execute anything. Okay. Understand?
If reset 1, then
Yeah. So one more thing, like we want to execute only on the rising edge, right?
yeah.
So we can write clock is 1 and clock tick event. So any event is there. Event means like either falling edge event or rising edge event. So this is we can write this way. Okay. This is a rising edge. Okay. And other way also we can write. One more way is there. This is also we can write directly.
Okay.
But we mostly write most of the time we write this. So both we can write rising or falling edge. Similarly, to make a falling edge, we have to make it 0. So event event when there is an event and the clock is 1. So in the clock uh, at this time event is happening. There's an event is happening and at the same time it is becoming 1. So this become rising edge. And there's an event and the clock is becoming 0. It become a falling edge. And this language understand this. Okay. It will treat it as a flip flop. Okay.
Mm.
So three things happened. So now when the reset is there, what will be the Q is always you remember I said Q will always be a 0.
Yeah.
When the preset is there, Q will always be 1. And when the rising edge is there, Q will be transparent to D. D will be transparent basically, and it will take the D value to the Q. Okay, so this becomes the basically the flop by this value. Okay, use output. That's why. So this generates the flop. Let's see what the tool does. Okay, what the language does. Okay, let's see what we elaborate this. What it will make out of it. This is very important, like to understand, like this is language, right? So really, what hardware is getting created?
Mm. Yeah.
That is called synthesis, like
Mm.
from the language to the hardware. You see, it has created a D flip flop, right? D.
Yeah.
So whatever input you give here, it will always take this cell. Okay, the cell is like D will be there, clear will be there, and preset is there. So clear is like a so it understand like when I want to make 0 output, it will that input it will correct to clear correct connect to clear, and whichever input I'm making to use uh,
Reset.
output 1, it will connect to pre.
Mm.
Okay, so let's I'll give you one. Let's say I'm making a reset. Well, let's say this is a name only. It That's a port only, port name only. It does not matter what port it is. I'm making Q as 1 here and Q as 0 here. Okay. So what will happen? You see, like I'm expecting this to go here and then this to reset to come here. Okay. Let's reload it. Yeah, preset by definition, we say, right? Preset will be doing the output one, right? But by mistake we change we did in the language in our code by mistake we did q as 0, so it has like changed it. Like it understand it is just a name, a port name. It can connect anything, but it will behavior has changed. Okay, the preset has connected to clear, and reset has connected to preset.
Mm.
Understand?
Yeah.
And then there's a clock and D and Q. Okay. Mm. It says right RTL register async. It understands like I'm making a asynchronous reset because Q is outside, right?
Mm.
Okay. And one more thing, this is rising edge. Let's make it a falling edge clock. What it does? So it will make the clock as a dot, I guess, and there have a circle there. Yeah, see, clock has become circle. So clock is inverted. So it's become falling edge.
Mm.
So
Yeah.
this is based on the coding, the hardware is changing. Okay. Mm. So what I will do, will make it uh, I'll copy paste it so that code is there, right? Otherwise, I have an understanding. So this is like what asynchronous preset reset and rising edge flip flop, right?
Yeah.
This is active high reset. Okay, asynchronous active high. Why active high? Because it is changing based on the reset and preset active high value. So now let's make asynchronous active high. This reset and the falling edge. I'm giving you multiple flavors of the flip flops. Okay,
Mm.
this we can comment. This already we have seen this also. Let's comment it. Already we have seen this. Let's okay. Let's reload it. This is oh we did right. Here should be 0. Active falling edge, right? So this become falling edge. Okay. And now for the reference, I change the comment also. Now I make the active low. Okay.
Yeah.
Rising edge only. Active low. Active low. What will this should the change should happen on the 0. Okay.
Preset on 0.
Preset and preset. So symbol will change again at this level.
That should be 1, I think.
It should be 1.
The the rising edge, the clock.
Yeah, rising edge. Yeah. See, it has made circle, put circle there. So it become a rising, falling edge, very active low reset preset, rising edge flop. Okay. I'd pick the cell basically based on that and then do it. And let's do the falling edge same. All three will be right. Too low falling edge. With this. All three. Okay. So we got four flavors of like rising asynchronous reset, right? Four flavors of asynchronous reset preset, like active high and falling edge, active high rising edge, active low falling edge, active low rising edge, right? Four flavors of asynchronous reset we got, right? Similarly, we can have a synchronous reset. Let's write a synchronous reset now. Okay. See it. This synchronous reset. Synchronous active high. Okay. And rising edge. Okay. So I said it synchronous means like the change should be only seen on the rising or falling edge of the clock. So when you want to see that change only there, then you must remove the reset preset from here. First of all, we don't want to see any change on that edge. We want to see only the change on the clock change, and it pick the value. Okay. So now we want to see that change, right? So what should happen? The clock should take the priority, right, over the preset reset. Then the clock. Let's get it. The clock should have a priority. Okay. The clock should be a top statement.
Okay.
And when the clock is active, then only anything should execute, right? So it means like it should be with that condition, right? So it should be inside that condition. Okay. If that is there also, if reset preset is there, right? So this is reset, and active high we are doing it. So this is active high. And when reset preset is done, otherwise you do the Q equal to D and else. So this there will be else part. Else this and this. Okay, so you see like anything will get executed only on the rising edge since the rising edge flop, and then on that condition, if reset is there, it will take this priority. If reset is there, it will take the priority. Otherwise, the Q will take the priority. D will take the priority. Last D, this is the last priority. Okay, but it will always get executed synchronously. Okay, so let's see how it looks like. So here, I guess there is no synchronous reset flop. It will put a logic outside. Okay, okay, this is a synchronous reset clock, and see it made RTL with sync, right? So basically, one more thing I want to say, tell you, what is synchronous is at flop. This showing here like this, but internally what is there? I'll tell you. Internally, it is like this. This is, and there is no reset. Okay, no reset. So it is taking sync a sync a sync flop. Okay, basically no a flop without any reset, and D is like this. So what is the priority? First is there is a mux here. Okay, or we can say the AND gate is there. So say mux is there, and so what is the mux input? This is a reset.
Hmm.
Okay, and when the reset is 0, and when the reset is 1. So when the reset is 1, it will take the value 0. This is the ground.
Hmm.
Okay, when the reset is 0, it will take it will check whether the preset is there. There is again one more mux. Okay, and here it's a preset. Okay, and this preset is 0 and 1. When the preset is 1, it will give us a VCC basically. Okay, and otherwise the D. This whole thing is there inside that box. This whole thing is there inside this box. Okay, it's not shown here basically. But this same logic is there inside. Same hardware is there. Okay, and why this is you can say, right, why it's not shown here? Why? Because this has to be like very fast executed, right? This has to be a very like fast cell, so it is custom designed in the like layout. You would have remember, right, layout design, right?
Yeah.
So it is done in the layout such that it is very fast, so that's it's like a group cell which is pre-designed with this logic so that it remains very fast. So there's minimum delay on this path.
You mean the hardware is designed, I mean, the FPGA hardware is designed like that?
Yeah, so it's a custom cell on the FPGA.
Okay.
It's not. I mean, so it's there already in the.
It exists already there in the FPGA.
Yeah, it exists already in the FPGA. So it's a custom. So that it is very fast cell. Understand? Similarly, like you can say, like this job is done by the backend engineers, which does the custom layout design, and then which is like replaced by this cell.
Okay.
Okay, so that's and one more thing. Uh, okay, that's fine. So you see, like, so if we go here and let's do a simulation quickly. Okay, how we see really. Other thing, anything else I want to see? I think four flavors we see there, right? And then one synchronous is it. And similarly, like if we can change a synchronous high, falling, all, it will change accordingly. It will put there. Okay. I don't think we can go. We want to do that, right? Four flavors here also will come.
Okay.
High, reset, falling, and you can do all the four flavors. So let's do a simulation quickly. How the waveform looks like. So we can copy this component here. This is- We can create signals. Okay. So now one more thing, we can create a port map also. Okay. Is it right? Instance name. So we can give a inst or dut design under test. Any name we can give. Please we remove. This is port map. Clock. Is it? This is one. Bucket is using Verilog. So I use Verilog also. So sometimes I mix by mistake the language. So now what we have to generate? We have to generate the clock, okay? And we have to generate the preset, reset, and D and Q, D only, basically. So one more thing, how we can initialize the signals also, okay? How we can initialize the signals in testbench? We can put this way, it will initialize the value, okay? So we want to initialize the zero, preset, reset, everything, okay? Let's make it 1. So basically initialize 0, any value we can initialize, it's up to us. So I want to give a 0 value as of now, beginning, okay? Then how we generate the clock in VHDL or any language. So basically, what is doing? Okay, you see the what is the clock? Clock is changing half after half the period, right?
Yeah.
Every half. This is the period of the clock, right? This from here to here,
Yeah.
the period. There is one period. This is two period. Okay. So every half the period, the clock is toggling basically. It becomes the inverted of the previous value. Okay. Every half the clock. So what we can write? The clock assigns the inverted clock. Okay. Inverted clock is not of clock. Okay. When it assigns after some time. Okay. Let's say I write 5 nanosecond. Okay. So 5 nanosecond, if clock is changing every 5 nanosecond, clock is inverting every 5. What is the period of the clock now?
So the positive edge and negative edge, that will be 10 nanosecond.
Yeah, 10 nanoseconds. So period is 10 nanosecond. This, yeah. Okay. So it means like 10 nanosecond period means like the frequency of the this clock I am running 100 megahertz. So now clock we generated. Now we generate the reset. Okay. So you remember we can drive the inputs like this also process and it will sequentially it will generate. Okay. Begin. So We wait for some time. Okay, wait for 100 ns. We make D here. Okay, right, first D. Anyway, D is 0, right? D is assigned 0. 30 nanosecond clock cycle basically. Then D we make again 20 nanosecond 2 clock cycle. We made D as 60. Okay. But before 20 we make let's say 18. Okay. We are making 2 from here, right? We make 18 basically. 18 and this become 2. So 18 plus 2, D is still changing after 20, right? So I make it here reset basically
Yeah, okay.
to see whether how reset is behaving. Okay. And then reset will not test. Only one test is enough, right? Nah, it's fine. Similarly, preset will also behave. And then we change wait for wait for 8 basically. And D assigns for 2. Maybe let's make it 12. D assigns take 1. This one. Okay. So let's see how it works. We're not testing preset because we know like preset and reset are similar behavior. Only one does the Q as 1 or one does the Q as 0. You see here, beginning the clock is 1. So clock is 1 here, right? So
Yeah.
it says D as a 0. So it make Q as 0, okay? And here at this falling edge, so this rising edge, it says D as 1. So you come D here, right? 1, okay? And at this rising edge, so rising edge did not occur yet, but the the preset has come, right? Sorry, reset.
Yeah.
But what is the edge flock? This is a rising edge. Uh, Say rising edge. Right? Rising edge, synchronous reset, right? We are seeing, okay. So rising edge synchronous reset. So it did not change, right? So even though the reset has changed, but it did not take place immediate effect on the Q, right? It take place here only because the reset is seen here, and then it has Q has changed here. Okay, it has not changed immediately here, right? It has changed here. The reset took impact here. Here. One more thing you can do. We can make one more cycle extend the D. We'll not make D here 0. Make D here 0. We will not make D 0. Okay. Leave it. We'll just make D remain 1. Okay. See, one cycle, the reset was 1 here. So at this time, it says that like reset is 0, reset is 1. So it make one cycle Q output 0. And at the time, at this cycle, the reset is 0. So it will take D value because D is in else, right? Last one.
Yeah.
So D is D, the Q change here. So now let's change the D flip flop design. So we comment it and we will make this first one. Okay.
Mm.
It's asynchronous, right? So we should see the change on the queue synchronously. So you see,
Yeah.
we did not simulate it or not. Oh, we did not need to re-level, right?
It's showing some error, I think.
Oh, okay, that's okay. You see, whenever the
Yeah,
reset
it's
is 1,
um,
it is immediately become 0. And when the reset is not 1, it goes to the next positive edge until, and there he sees the D1 and then it makes the Q1.
mm, yeah.
So yeah, so it's quite different behavior when the reset is synchronous and when the reset is asynchronous.
Mm.
Okay. Mm. So next class we'll cover the latch, okay, and then maybe some shift registers, and then also we will talk about the some timing like what is setup time and hold time for the flip flop. Okay, to understand some timing related thing a little bit as of now.
Mm, okay. And this, can you zip and send me this code, this folder?
Yeah, yeah, I'll send you. I'll send you.